Hi, students. All right, let's do this. First question I want to ask you is a conceptual question. We have two different cases where we have an unknown charge, little q, here in the middle. And in one case, we have a positive charge and then a negative charge. In the other, we have two positive charges. What I would like to know is in which case 1 or case 2, the force on that little q is bigger. And your answer could be case 1, could be case 2, or your answer could be it depends on the sign of little q, because I'm not telling you if little q is positive or negative. So what I would like you to do now is to go ahead, pause the video, think about this, see if you can figure out what your answer is. Did you pause it? I hope so. Okay, let's talk about it. So let's first imagine the scenario in which plus q is positive, or little q is positive there. In this case, these guys would repel, and these guys would attract. So it's got two forces pushing it downward, the repelling from the top force and the attraction from the bottom one. In this one, if this middle q is positive, it's repelled by the top one, and it's also then repelled by the bottom one, and so our net force here is 0. So if it's positive in the middle, the answer is definitely that this has a force on it, this does not. Now let's test it if it's negative in the middle. Now it's negative. Okay, in this case, now these two are attracted, so this feels an attractive force. These two are repelled, it feels a repulsive force. This one is attracted by the top one, and this one is also attracted by the bottom one. And so again, that's 0. So once again, we have a force here in case 1, no force here in case 2. So the correct answer is case 1. All right, so that is a conceptual question, and what I really want you to get out of this, besides just this particular answer, is figuring out how to handle it when we have more than two charges and we're using Coulomb's law, right? So we have to think about the force on this one due to that guy, and the force on this one due to that guy to get the total net force on those inner charges. Notice I'm not drawing any arrows up here or down there or there, because I'm not talking about the forces that they're experiencing. I could, but that's not what the question is about. We're looking at the force on this particular charge, so I'm going to draw arrows representing each separate force it feels from each separate charge, and then use summation, specifically when we get into two-dimensional stuff, vector summation, these are vectors, these forces, right, to figure that out. All right, so here is my first video.